So this is the chapter 13 review. X equals what, class? 13.6. 13.6. Just be careful, if this had units, then you should include units. 13.6 feet. The next one, what trig ratio should we use? Cosine. So we have cosine of 25 degrees equals adjacent over hypotenuse, x over 9. And what do you get for x? 8.2 units, whatever the units are. Solve ABC. Notice ABC has a right angle, so you don't have to use law of cosines or law of sines. You can just use trigonometry. So if we draw ABC, C is the right angle. We'll put A up here, B down here. Doesn't really matter where you put A and B, just be consistent. So you should get the same answers that I get on the board if you switched A and B. How do we find the length of the hypotenuse? Pythagorean theorem. Pythagorean theorem would be 9 squared plus 17 squared equals AB squared. And what do you get for AB? 19.2. 19.2. And then you just have to find one angle with the trig ratio. So we could do angle A. We could do sine of angle A equals. It might actually be nicer to use tangent. Since we rounded 19.2, it might be nicer, instead of using that rounded answer and using sine, we could use 9 and 17 if we do tangent of A equals 17 over 9. And when you do that, inverse tangent of 17 over 9 is 62.1 degrees. 62.1 degrees. So there's that. There's that. And then how do we find angle B? Subtract from 180 or subtract from 90 since it's 90. So that would be 27.9 degrees. So that solves. Make sure when solving triangles you solve for everything, the angle and the side. Okay, airplane climbs at an angle of 11 degrees with the ground. Find the ground distances traveled when it's attained at altitude of 400 feet. Altitude 400 feet. Here's the plane. Plane. 11 degrees. Angle of elevation is with the ground, so going up 11 degrees. Altitude's perpendicular, so you don't have to use law of sines. If you want to, you can, but you don't have to do law of sines. You want to know the ground distance, so what trig ratio should we use? Tangent. Tangent of 11 degrees equals 400 over x. In solving this, you multiply both sides by x and then divide by tangent 11 degrees. And what answer do we get? 2,057 feet. So you just round to the nearest foot. It's probably most realistic. Converting from degrees in radians. So 60 degrees, you multiply by pi over 180. This was actually a quiz question. A lot of people put 3 pi. Well, maybe not a lot, but like 3 or 4 people, more than expected. Be careful, 180 is bigger than 60, so the 3 is in the denominator, not in the numerator. So it's pi over 3 radians. And this one you should get 180 over pi. The pi's cancel. 180 divided by 4 is 45. 45 times 11 is 495. And remember the degree mark. So 495 degrees. On these, I think on the actual test, I'll give you coordinate planes or axes. So hopefully that will remind you what I'm expecting you to do. You draw the angle. This is 30. This is negative 1. This is 2. So this would be negative 1/2. Sine of 330. Cosine of 135 would be in the second quadrant, 45 degree. This is 1, this is negative 1 square root 2, so that would be negative square root 2 over 2. Sine of 180, quadrantal angle. Don't draw a triangle, 180 degrees. What are the coordinates of that point? negative 1, 0, and sine corresponds to what? The y. Big donut, the y variable. 5 pi over 6, you could change it to degrees if you want, but it's going to be in the second quadrant with a 30, so that would be 1/2. If you changed it, I guess it would be 150 degrees if you change it. 3 pi over 2 is a quadrantal angle, and you have what ordered pair? 0, negative 1. Secant is the reciprocal of what function? Cosine. So cosine is the x, which is 0. So the reciprocal of 0 is 0. It's actually undefined.
Oh.
Yeah, and you can think of it that way. If this is cosine 0 over 1, the reciprocal would be 1 over 0, which is undefined. U and b, you could do either one. Undefined solution. And if you don't believe me, you won't actually be able to use calculators on this part, but just to show you that that's true. Oh, 3 pi over 2 is 270. So you would get division by 0 is undefined. And then tangent of 9 pi over 4. 8 pi over 4 is 2 pi. So this must be an extra pi over 4, which is in the first quadrant. So you have an angle that's, I guess that would be 360 plus 45, 405 if you changed it, 405 degrees. So you would have, tangent would be 1. Positive. Positive 1. This is plus, this is plus. Not that you can see those, but on the next page, solve the triangle. Oops. Find the area of the triangle. So what's the area formula for a triangle? 1/2. Yeah, in this case, 20 times 27. Sine of 85 degrees. So anytime you're given the side angle side, you can use this formula with the included angle. So if I happen to give you an angle up here, it doesn't really matter. Ignore that. That's me trying to distract you from the goal. The goal is to use side angle side, where the angle is in between the two sides. What answer do we get for the area?
260.
To the nearest 10? 1/0. And I don't know what the units, but it would be square units. I do know the units. Oh, I can fix this. Centimeters squared. Solve the triangle. So, let's see, angle AB. I like it if you put AB at the bottom. You got angle A is 25 degrees. Across from A is 13. Across from B is 12. So the first step, when we set up sine, law of sines, this is the side-side angle case. How many possible solutions are there with a side-side angle case? You could have one solution, two solutions, or 0 solutions. So sine of 25 over 13 equals sine of 12 over... Excuse me. Sine of b over 12. And what do you get for angle b? 23 degrees? And then you could solve for side c. So we got that. Oh, angle c would be 25 plus 23, 180 minus that. So what's that? 48, 132? So there's angle C, there's angle B, and then what did you get for side C? 22.9 units, whatever it is. We could have a second solution. Maybe. How do you check to see if there's a second solution? So my diagram's not going to be really helpful, but we'll say these are congruent. We'll just say they're both 13. So if they're both 13, this angle B and this is isosceles, so that would be 23 degrees. So what's angle B prime? 157. So if you have angle B prime is 157 degrees, angle A is 25 degrees, how much is angle C, or C prime? -2 degrees. So there's only one solution. There's no second solution. And next, we have 39 degrees. A, B, C, B, A. I'm really mean, I guess. I gave you another side-side angle case. Tisk, tisk. So what do you get for angle B when you solve? 61 degrees? 62 degrees? 61.9 or something? 0.8? I notice how I'm numbering my steps. It's kind of nice if you do that, because sometimes you start writing everywhere like this. Looks like a mess, but at least I can follow 1, 2, 3 on this side. And then angle C would be 180 minus 62 minus 39, and what's that? 79 degrees. And then the lowercase c would be what measurement? 15.6. And is there a second solution? Uh-oh, I'm running out of space. Second solution. So these are congruent. Angle B is 62 in here. So that means angle B prime, which is really angle A, B prime, C, would be 118. New angle C prime, which is really A, C prime, B prime, would be what? 23 degrees. And then what's the new measurement for C? It should be less than 15.
Yes,
6? So be careful about this one. You have two solutions. And let's see, for this we have A, B, C. So should we use law of sines or cosines? Law of cosines. This is side angle side. You use side angle side for cosines. You could try to use law of sines and you're not going to get anywhere. So you would say, how do we set that up? We have
3 squared is equal to 100 plus 49 minus 2 times 70 cosine 70.
There you go, thank you. So then C would equal what? 10.4. And then we could use law of sines. Sine of 73 degrees over 10.4.
So it's sine A over 7.
Why pick A before B?
Because A comes before B.
Oh, isn't that nice? Sine A over 7. So what's angle A? 40? And then, whoops, C. Angle B would be 67 degrees. There's no possible second solution with law of cosines case, which is nice. Whew. A lot. A, B, C. Across from C, across from A, across B. And what do we use here? Well, cosines or sines? Cosines. This is side angle side. So it's really similar to this one. Going to be similar work. So what did you get for side C? Side C?
That's really good.
Oh, sorry, side B. 17.9. And what are the angles?
A is 55, C is 78.
A is 55, C is 78. Oops. So you could check your answers on that. The last two questions, graphing. So graph sine x, you're gonna label it. We'll do this 2 pi, out here is negative 2 pi. How high and how low does it go? 1 and negative 1. So that's going to be your range, negative 1 to 1 for both. Negative 1 to 1. Pi, negative pi, negative pi over 2, positive pi over 2, 3 pi over 2, negative 3 pi over 2. And the sign looks like this. Remember, draw U's to make it look nice. Whoa, man. On fire. So that's a sign. The domain's all reals. You could also do negative infinity to positive infinity. And then cosine. Man. How do I do that? It says to do negative 2 pi to 2 pi, but just to remind you of what the angles are. The angles would be, still goes to 1, negative 1. The angles would be 360, negative 360, 180, 270, 90, negative 90, negative 180, negative 270. And you have, whoops, cosine starts at 0, 1. So that's a graph. Make sure you know how to state domain and range. It's the same for both. Thank you for watching this video.